Okay, yeah. All right, so guys, as I said, so the final, okay, so let me just remind you, so the final, um, the final, so it's gonna be next Wednesday, right? So it's next Wednesday. Oops. So it's next Wednesday. No, Crystal. So I'm gonna take it easy today. So I won't take attendance because it's a last day of classes. You know. So no. So I won't take attendance today. Yeah. Um, how many questions? Let me see in the chat. I'll be in the exam. Well, so the final it's from 9 a.m. right, from 9 a.m. to 11:50. So that's almost 3 hours. So I don't know exactly the number of. So it's my final, right? It's I'm gonna make the final. So, but I didn't I didn't make it yet, so I don't know exactly the number of problems, the questions in the final. But I would say, so in the second test, we had how many problems in the second test? It's six, I think 6 problems, right? So 6 problems. That's for 2 hours and 30 minutes. So I would say in the final you would have probably about 8 problems. All right. Um, so, but again, it's just an estimation, right? I don't. No, Ibrahim, I won't take the attendance today. I'm gonna just. Yeah, about eight problems, currently, I would say. Yeah. Mm-hmm. So, yeah. So next Wednesday. It's 16th at 9 a.m. guys. Okay, so this is really important. It's at 9 a.m. It's not at 10 a.m. It starts at 9 a.m. All right, so it's from 9 a.m. to 11:50 a.m. All right. So again, it starts at 9 a.m. This is really important because if you start your test at 10 a.m., then you would have like 1 hour less, okay, to do the exam. All right. So it's really at 9 a.m. So I'm gonna post the final as usual, on Blackboard at 9 a.m. and then you have to submit your answers on Blackboard, or just email me your answers to. So I would prefer that you send me your answers to my Gmail, guys, because again I have a problem with the space. I don't have enough space in my BCC email, so I prefer that you send me your answers to my Gmail. Okay. So yeah, I was saying so the final would cover everything. Okay, it's not so cover. So it will cover everything. Okay, so everything we did so far will be in the final. Okay, in theory, of course. So I would say the best thing you can do, guys, is I mean, if you have your first test and your second test, the best thing would be to make sure that you know how to solve the problems in the first and the second test, because again, the problems you had in the first and the second test, this is like the standard problems, and for sure you're going to have similar problems in the final. All right, so make sure that you know how to solve all the problems in the first and the second test. All right, plus you're going to have one more problem about the trick. So one more problem. No worries, Irada. I'm not taking the attendance today, so I'm gonna take it easy today. So it's the last day of classes. So yeah, so one problem about the trick. And I would say this problem would be similar to the problem in the homework, problem number 2 in the homework 8. Okay, so about the trig functions. So this problem would be similar to the problem number 2 in the homework 8. Okay, to problem 2 in the homework 8. Okay, so again, I would say it's going to be about 8. I would say 8, 9 problems. So basically, we're going to have some problems from the first test, plus some problems from the second test, and one problem which is similar to the problem number 2 in the homework 8. Okay, one problem above the trick. All right. Okay, guys. So if you can find your first test or your second test, that would be awesome. So I'm gonna go over the second test and also the first test. I mean, of course, we won't have enough time, but I'm gonna try to do my best. But first, do you have any specific question about the test number 2 or the test number 1? Okay, so take a look to the second test and to your first test. Okay, and let me know if you have any specific question. I can go over any problem in the second or the first test. All right, so again, because in the final you're going to have just similar problems from the first, second test, and I'm going to do also one problem about the trick, similar to the problem number 2 in the homework 8. Okay, so again, okay, guys, so let me know if you have any specific question about the second test or first test. Just let me know. All right, the inequalities in the second test. Okay, that's perfect. Okay, so I can start with that, I guess. All right, so let's see. All right, so this is a problem. Okay, so problem number 2. I didn't grade yet the second test, but I will, I guess, on Friday. So I hope this weekend you get your grade, your test number 2 grade. Okay. So this is problem number 2 from the second test. Right, so the inequality. So this is you have to solve. So x minus 2, x plus 6 over x plus 1 over x plus 4, less or equal to 0. To solve such a problem, guys, there are two main steps. So first step, you have to solve when the top and the bottom are equal to 0. So step 1, so you have to solve the top equal to 0 and the bottom equal to 0. Okay, so the top is going to be 0 if, so the top, that's the x minus 2 times x plus 6 equal to 0. Of course, this is a product equal to 0, so either the x minus 2 is 0 or the x plus 6 is 0. So then your x is positive 2, or your x is negative 6. All right, and then the bottom equal to 0. So that's x plus 1, x plus 4 equal to 0. So either the x plus 1 is 0, so then x is negative 1, or the x plus 6 is 0. So your x is, sorry, x plus 4. I said x plus 6. Sorry, this is x plus 4. X plus 4 is 0. So your x is, of course, negative 4. All right, so we have 4 solutions. So we have this x equal to plus 2, negative 6, negative 1, and negative 4. All right. Now, Khadija, the second step is the chart. I really recommend to do this chart because I think that's the best way to, to solve the inequality, because otherwise it's easy to get confused. So this step number 2 is the chart. So what we do in this chart, we So you have your number line going from negative infinity to positive infinity. And on this number line, you're going to put the solutions you got in the first step. So we got -6. So here's my -6. We got -4. So here's my -4, -1, and +2. All right. So you put on your number line, you put all the solutions you got from the first step. Now, this means we have actually, you can see it here on this number line, you have like 1, 2, 3, and then 4, and then 5 different intervals. All right. So we have 5 different intervals. And then, so now we're going to put the factors. So we're going to have let's say we're going to have 4 or 5 rows. So in each row, we're going to put the factors. So first factor we have this x -2. That's our first factor. So I'm going to put x -2. Second factor is x + 6. So here's my x + 6. The third, in the bottom, we have x + 1. So I'm going to put x + 1. And then we have this x + 4. Okay, so I'm going to put the x + 4 here. All right. And in the last row, I'm going to put my function. So it's my function f of x. So my f of x is, so it's the x -2 times the x + 6 over x + 1 times the x + 4. Right. Now, so we have now a line coming from each number here on this number line. So from -6, here's a line representing -4, another line here representing -1, and this line here represents +2. So what we're gonna do, guys, now is we're gonna try to figure out the sign of each of the factors. So you start with the x -2. Right, this is your x -2. This is your first factor. So what we do, guys, is we're gonna pick like a random, numbers in each interval. So like here, this is my first interval from negative infinity to -6. So I'm gonna pick a number between negative infinity and -6. So let's say it's -7. Here between -6 and -4, I'm gonna pick, let's say, -5. Between -4 and -1, I'm gonna pick, let's say, -2, and then from -1 to 2, I'm gonna pick, let's say, 0, and from from 2 to positive infinity, I'm gonna pick, let's say, 4. And what I'm gonna do, I'm gonna plug numbers in my factors. So first factor is x -2. So I'm gonna plug -7 in x -2. So that's -7 minus 2. It's -9. So in the first interval, x -2 is gonna be negative. So here's negative. Next, it's -5. -5 minus 2, it's -7, which is negative. -2 minus 2, that's -4. 0 minus 2, it's -2, so it's again negative. And then 4, right? I picked 4 here, right? So 4, I plug 4 in x -2. That's 4 minus 2. That's +2. So it's going to be positive, right? And so now you move to the next factor, which is x + 6. You plug -7 in x + 6. That's -7 + 6. That's -1. So it's negative. -5 + 6. That's +1. -2 + 6, that's +4. 0 + 6, +6. 4 + 6, +10. Right? X + 1, you plug -7 in x + 1, -6. -5 + 1, -4. -2 + 1, it's -1. 0 + 1, it's +1. And 4 + 1, of course, that's +5. X + 4, Negative 7 plus 4, it's negative. Negative 5 plus 4, it's negative. Negative 2 plus 4 is positive 2. 0 plus 4 is positive. And 4 plus 4 is positive 8, of course. Okay. Now, guys, just be careful. So now, next thing to do is to multiply in each column. You're going to multiply the signs, right? So like in the first column, it's minus times minus, that's a plus, times another minus, that's minus, times another minus, that will be a plus. So when you multiply the signs in the first column, you're going to have a plus. In the second column, minus times a plus, that's a minus, times another minus, that will be a plus, and then times another minus, that will be a minus. So here, when you multiply the signs in the second column, that will be negative. Negative times positive, negative times negative, that's positive, times another positive, that's positive, right? Now, fourth column, negative times positive, negative, and then times positive is going to be, of course, negative. Last column, everything is positive, so when you multiply, it's going to be positive, right? So you see, guys, now I know exactly the sign of my rational function, right? So it's like, so here I have a plus. It means that my function f, my rational function f, is going to be positive on the interval negative infinity, negative 6, right? Etc. Now you come back to the question. So the question was when your f of x is, so the question is when the f of x is less or equal to 0, right? So so the original question was x minus 2 times, so this is your f of x, right? So x minus 2 times x plus 6 over x plus 1, x plus 4. So we have to solve when this f of x is less or equal to 0. Okay, so so this is less or equal to 0. So less or equal to 0. So when you are less than 0, it means you're negative, right? So the question is, when my function is negative? Well, it's negative right here, right, in the second interval and in the fourth interval. Okay. Now, what about the equal to 0? Well, so you see, guys, here when x is negative 6, right? So when x is negative 6, the top is going to be 0. So we have 0 here. We can put a 0 on this line here because this line represents, negative 6. And what I'm saying with this 0 is that when x is negative 6, my function f is going to be 0, right? The top is going to be 0 when x is negative 6, so the whole thing is going to be 0, right? And also when x is positive 2, right? So if x is positive 2, the top is going to be 0, so then the whole thing is going to be 0. So here, here's the line representing positive 2, and I'm going to put the 0 here because when x is positive 2, the whole thing is going to be 0. Now, you may ask, what about the negative 4 and negative 1? Well, the thing is, negative 4, if x is negative 4, the bottom is going to be 0. So if x here is negative 4 plus 4, of course, is 0. So the bottom is going to be 0, but we are not allowed to divide by 0. Okay, so that's why I won't put the 0 over on the line representing negative 4 or negative 1, right? Because when x is negative 4 or x is negative 1, the bottom is 0, and we are not allowed to have 0 on the bottom. Okay, so to answer the question is, so the answer to the question would be, so again, we are interested in when the function is negative, less or equal to 0. Okay, so again, this is a negative or 0. So it's going to be negative here in the second interval. This is the interval, negative 6, negative 4. and also negative here, that's -1 and +2. So it's -6, -4, -1, and +2. So so the answer would be, so it's -6, -4, right? That's this is this interval here, this one here, -6, -4. Now, do we include -6? Well, as I said, if x is -6, the top is going to be 0, right? Because you have here, if x is -6, then the top is going to be 0. So the whole function f is going to be 0. And in the inequality here, in the question, it's less or equal to 0. So it can be equal to 0, right? So it can be equal to 0. So we include the -6. Right? Now, do we include -4? Well, if x is -4, as I said, the bottom is going to be 0, and we are not allowed to divide by 0. So we exclude the -4. Okay. Union. Now, the next interval is this one here. This is when my function is negative, right? And that corresponds to the interval, this one here, from -1 to +2. So from -1 to +2. So here's my -1 to +2. Do we include -1? Nope, because that means that the bottom would be 0. Do we include +2? Yes, because if x is +2 here, and the top would be 0, so the whole thing is going to be 0. And again, guys, because of this line here, my function f can be equal to 0. So yes, we do include the +2. All right. So does this make sense to you, Khadija, too? Yes, perfect. All right. Is there any other question about this problem, guys? About these inequalities. So again, guys, I really recommend to do this chart, okay? Because I think that's the best way actually to answer this question, right? I know some of you had like different way to answer this question in the homework, and sometimes it seems like it's not clear how you got the answer, right? But here with this chart, I think it's very clear, right? So you have the sign of each factor, you know exactly when each factor is positive or negative, and you know exactly when your function, the whole function, when the whole function is positive or negative, right? So I think this chart I really recommend this chart in the final. If you don't do this chart and your answer is not really justified, is not clear, you won't get the full credits, okay? All right. Is there any other question, guys, about the test number 2? I think some of you, I think first problem, so it's about the polynomial. I don't know if you had the trouble with factoring f of x. I didn't grade the test yet, so I don't know exactly where people had problems. But let me see.
Professor, I have a question.
Yes.
I have
Yes.
a question about
Yeah, sure.
last problem of the second test of the
Last problem.
yeah, the last problem.
Problem number 6.
Yes, please.
Okay, the exponential equations.
Yes, please.
The first or the second?
The first one.
Sure. Both of them, or
yeah, the both.
the first?
Yeah. Right.
Both. Okay.
Yeah, both.
All right.
Please.
Okay. Sure, no problem.
Right.
So this is problem 6. Test number 2. All right. So first equation, so we have this 2 to the power x minus 1 equals to 3 to the power minus 2x plus 1. All right, guys. So this is called an exponential equation because in the base you have a constant. So when I say the base is this number here, that's what I call the base. So in the base you have a constant, and in the exponent you do have an x, right? There's an x in here in the exponent. X is my input. That's my variable, right? So when you have a variable in the exponent and a constant, this is a constant, this is just a number, right? In the base, so constant here, x is in the exponent, then that's what I call exponent. That's what I call, because x is an exponent, that's what I call exponential function, because your x is an exponent, right? So so this is called an exponential. So this is an exponential equation. So this is called. So this is an exponential function. Exponential. So in the word exponential, there is the exponent. You see this exponent in the word exponential because your variable x is in the exponent. Okay, so this is an exponential function. All right, so this is called the exponential equation. Now, in general, called an exponential equation. So, I mean, I would say, so the very general way to solve exponential equations is just to apply natural log to both sides. Okay, that would work in any case. Okay, so as a general rule of thumb, so you can just apply. So the idea is to apply natural log. So this is ln, that's what I call natural log. Apply natural log to both sides. Both sides. All right, so I have, here's my natural log. Here's my natural log. All right. On the left side, I have 2 to the power x minus 1. And on the right side, I have 3 to the power minus 2x plus 1. All right. So why do you apply natural log, or why do you apply log anyway? Well, this is because one of the main property of the log functions is that you can bring down the power. So this power here, this is exponent here, this x minus 1, you can bring it down here in front of the log. So the same here for this your exponent is minus 2x plus 1, right? You can put it here in the front of the natural log. All right, that's one of the main property of the log. Okay, so again, because there's you have your x in the exponent, and that's a problem. Okay, so because it's you don't know how to deal with the x in the exponent. So the idea is to bring it down using the log. Now, once you have your x minus 1 in front of the log, so here's your x minus 1, right? That's your exponent times your log. So when you put down this x minus 1, you are left with 2, right? So this is natural log of 2, right? This is 2 here, right? Equal to, and here on the other side, the right side, you have minus 2x plus 1 times, you bring it down the minus 2x plus 1, so we are left with 3. So that's natural log of 3. All right. Now, guys, I know some of you are scared of this natural log, but again, think of this natural log as like this natural log of 2, it's just some decimal. All right. It's, I don't know, it's 0.6 or wherever, but it's just a decimal. This is just a number. It's a decimal. All right. This is just a decimal. Same here for this natural log. It's just, I mean, if you use a calculator, I think natural log of 3 would be 1 point something. But it's just a decimal, right? So you think of this natural log of a number as it's just a number. So now I want to solve for x, right? So in general, how do we solve for x if you have such an equation? Well, first you expand both sides. So you you multiply x by this natural log of 2. This x here times this natural log, and then this 1 here times the natural log. Same here for minus 2x times the natural log of 3, and plus 1 times the natural log of 3, right? So you multiply x by natural log of 2, then minus 1 times the natural log of 2. On the other side, the right side, minus 2x times this natural log of 3. okay, plus 1 times this natural log of 3. Okay, so now, well, so you see, guys, you have an x on the left side, there's an x on the right side. Of course, the idea here it would be to put the x's on the same side, right? Because then if you put the x's on the same side, you can factor out the x. X is going to be a common factor, so you can factor out x and you can solve for x, right? So you have to move all the x's on the same side. So I'm going to move this minus 2x times ln of 3 to the right side. It's a minus, so I'm going to need a plus. So it's plus 2x times natural log of 3, right? So I'm going to do the same thing here. 2x times natural log of 3. So again, guys, natural log of 3 is just a number. I don't know exactly what's I mean, I need the calculator to find this natural log of 3, but I don't really care. I'm going to just keep the natural log of 3, right? So again, it's just a number. So now, I can cancel out this. So on the left, I'm going to have x times natural log of 2 plus this 2x times natural log of 3. And then there's this minus 1 times natural log of 2. 1 times any number is going to be just the same number. So it's minus natural log of 2. And on the right side, it's just 1 times natural log of 3. So it's just natural log of 3. Now I have my x's on the same side, right? And so I can factor out the x, but then I have to move the constant, where the terms with no x to the other side. So this minus natural log of 2. So there's no x in this term, right? There's no x in here. So I'm gonna move it to the other side. So it's a minus. So I'm gonna need a plus natural log of 2. So it's a plus natural log of 2. All right. So then now it's just minus plus, cancel out. So it's just x natural log of 2 plus 2x natural log of 3 equals to natural log of 3 plus natural log of 2. Now I have my x's, all my x's on the same side and all the constant on the other side. So now x is a common factor. This x, you see this x here is a common factor, so I can factor out this x. So here's my x times, well, x times this number here, natural log of 2. Again, it's just a decimal. I don't care. I'm going to just keep the natural log of 2. So it's just a natural log of 2 plus, you pull out this x, so you're left with this 2 here, right? And this natural log of 3. So it's plus 2 natural log of 3 equals to natural log of 3 plus natural log of 2. Now, it's because it's x times some number, then I can just divide by that number. So I'm going to divide by this natural log of 2 plus 2 natural log of 3, both sides, plus 2 natural log of 3. All right, and so once you divide by the same number here, so this number here and this one, they cancel out because it's just the same thing. So they're going to be equal to 1. So it's just x now on the left side. And on the right side, I'm going to have this natural log of 3 plus natural log of 2 over natural log of 2 plus 2 natural log of 3. All right, and that will be the answer. All right, any question? Let me see the chat.
Professor.
Yes, please.
So can you use normal log? Can you use log to solve this?
You mean natural log or a log in different other base?
Like can you take log base 10 in both of them instead of like ln base e or something?
Yeah. Actually, you can take a log in any base because once you apply the log, you can bring down the exponent. But I mean, I'm using natural log because it's sort of a convention, right? It's a sort of a very common thing to use natural log. It's called natural, right? In the natural log, there's the word natural. So it's a very natural thing to use natural log to solve these exponential equations. But you are right. I mean, I can use a log in any base. Instead of this base e, I can use log in base 2, for example, or base 3 for both sides. And still have you can still solve the equation, right? And you're gonna get the right answer. So yes, so to answer your question, yes, you can use actually any log. Any base, and you will be able to solve the equation.
Okay. Thank you.
Again, I'm using natural log because it's natural. It's sort of a convention to use the natural log. You know. Yeah. Any other question, guys? But here, you see here, I'm using natural log because you see this 2 and 3. So these two are exponential functions, but different base. Here, this is base 2, and here it's a base 3, right? So it's just a different base. So I'm just using natural log. But of course, if you have the same base, if you had, here's 2, and let's say here also we have 2. All right. So if you have two, if you have the same base, then you can just use a log in base 2. Okay. And actually, if you have the same base, then it means that the exponent, they're gonna be equal. But anyway, so this exercise, it's 3 here, and so yeah. All right. Any other question about this problem? All right. So now let me do the next, the exponential e to the 5. So the next, so the second part of this problem number 6. So the part 2. So this is b. Let's say so it's e to the power 5x minus 2 equal to 1. Right. Again, the e, it's just it's just a decimal. It's approximately, I think, 2.71 something. It's just a number. But again, the thing is, in physics, or I mean, if you take a calc 1 class, you will see why this number e is very special. Okay, but anyway, so as I said, this is an exponential function because this is a number. This is a constant, right? This is a constant, and in the exponent, you do have x. X is in the exponent, so this is an exponential function, and of course is in the exponent. So this is an exponential function, so you can just apply as I said, this is exponential equation, so you can just apply natural log. Okay, so I'm gonna apply natural log as usual. So here's my natural log left, natural log on the right. Here's equal. So on the left, I have this e to the 5x minus 2, and on the right, it's 1. Okay. So so again, we are applying the natural log because this I can put down this bring down this exponent 5x minus 2 in front of the log. So now we're gonna have 5x minus 2 times its natural log of e equals to natural log of 1. Okay. Now, guys, I have to remind you, first, natural log of 1, we said in the course, log in any base, log in base a of 1, this is always 0. Okay, it doesn't matter the base. In any base, log in base a of 1, log of 1 is always 0. Okay, so this natural log of 1 is equal to 0. Okay, so again, keep in mind, guys, log of 1 is always 0. Now, what about this natural log of e? Well, that's so just to remind you guys, a log, if you have a log of a in base a, log of a in base a. So if you have the same, so if you have a in the base and inside the log, So then this is always equal to 1. All right. So here, if you have natural log of e, so natural log by definition is log in base e, right? So we have natural log of e. This is by definition log in base e, right? That's a definition of natural log. It's log in base e of e. So you have the same thing in the base and inside the log. So that'll be equal to 1. Okay, so what I'm saying is that this natural log of e is equal to 1. All right, so it's just now. So now it's just 5x minus 2 times 1 equal to 0. Right, because natural log of e is 1 and natural log of 1 is 0. So this is just 5x minus 2 is equal to 0, plus 2 both sides. So that's 5x equal to positive 2. And then you divide by 5, both sides. So then your x is 2 over 5. And that's the final answer. Okay, so again, guys, you have to, I mean, you have to know by heart these two properties of the log. Log of 1 is always 0, doesn't matter the base, all right? And log of a in base a, that's always equal to 1. Okay. Any question, guys? So as I said, when you have this exponential equations, and probably you're gonna have in the final, you're gonna have to solve, I guess, a logarithmic equation and an exponential equation, right? So I mean, you should expect in the final to have such equations. So as I said, general rule of thumb, just apply natural log both sides, and you should be fine. Any question, guys, about this problem number 6, or any problem in the second test? So as I said, second test, we had a problem about the graphing polynomial functions, inequalities, solving log. I don't know if you guys had the trouble with solving a log equations. Number 4, rational. Let's see, number 5. I think some of you had trouble with number 5. So probably I can do that, unless there's a specific request.
Sure, we can do that. Yeah.
No. Okay. All right. So all right, so then let's do this problem. So this is problem 5 from the second test. So we have to solve x cubed minus 6x squared plus 11x minus 6 equals 0, given that x equal to 1 is a solution. So when I say x equal to 1 is a solution, it means that if you plug 1 in the equation, all right, then you're gonna get 0, right? So in other words, if you replace x, if you replace x by 1, so if you do like 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6, so that'll be 1 minus 6 plus 11 minus 6, that'll be equal to 0. Okay, so 1 is a solution, right? So guys, remember, we said, I'm not section, I think it's section 2.4 or 2.5, but if you have a solution, if x equal to 1 is a solution, it means that x minus your solution is a factor. So what I'm saying is, your function f is of course is this x cubed minus 6x squared plus 11x minus 6, right? You want to solve f of x equal to 0. So what I'm saying is that if x equal to 1, x equal to 1 is a solution, then So then x minus the solution is a factor of f of x. Okay. So what do I mean by x minus the solution is a factor? It's like saying, let's say you have number 8 and you are saying 2 is a factor of 8, right? 2 is a factor of 8 because 8 is divisible by 2, right? So when I say a factor of f of x, it means, in other words, it means that f of x, like, so what I'm saying here is that f of x is divisible. It can be divisible by this x minus the solution, right? So that's what I mean by x minus solution minus the solution is a factor of f of x. Is in some sense it's divisible by x minus the solution. So when you divide f of x by your x minus the solution, the remainder is going to be 0. Okay, so what we have to do now, guys, is just we have to divide. So first step, you have to divide. So step 1, we have to divide your f of x by x minus the solution. So divide f of x by x minus the solution. So it's x minus 1, right? So I'm going to divide this f of x by x minus 1. So this is division of polynomials. So remember, guys, we said this is like x minus c, right? So here in this case, your c is positive 1, right? The c is the opposite of the this number here, right? It's minus 1, so their c is positive 1. So c is just your solution. So let's divide. So division. So remember, guys, how we do the division. So I'm going to put the c here. This is positive 1. And here I'm going to put my f of x, which is x cubed. So it's 1x cubed. X squared, we have minus 6x squared. How many x's? We have 11x. And how many constant? We have minus 6. So the constant is minus 6. All right, so you bring down the first, always bring down the first number here. This is 1. You multiply by the c. You multiply here, multiply. So 1 times 1 is 1. So I'm going to put 1 in the next column. And now we're going to add. So negative 6 plus 1, it's negative 5. You multiply negative 5 by 1, that's negative 5. 11 plus negative 5, it's 11 minus 5 or plus negative 5, it's 6. 6 times 1 is positive 6. Minus 6 plus 6 is 0. So you need to get 0 in the last column, last row, because that's supposed to be your remainder. And because we said f of x is supposed to be divisible by x minus the solution. So the remainder must be 0. So if you don't get 0 here, guys, it means that you did a mistake somewhere. Okay, so this is the remainder, and that's what we expected. We expected 0 as a remainder because f of x is divisible by this x minus 1. Okay, so my remainder is 0. That's good. Now, the quotient, it's always 1 degree less. I mean, if you have here is x cubed, so here it's 1 degree less, so it's going to be x squared. Here it's x squared, so here's x. Here's x, so here it's going to be constant. All right. So, so what we are saying, guys, is that remember your f of x is supposed to be equal to. So we divide the f of x by the divisor. We divide by x minus 1 times, here we are supposed to have the quotient, and here plus the remainder, right? Now, f of x is going to be x minus 1 times the quotient, which is 1x squared minus 5x, and constant plus 6. So 6, and then the remainder is plus 0, right? This is supposed to be plus 0 because the remainder is 0, so it's a plus 0, so you can just forget about this plus 0. So you see, guys, your f of x is a product. It's a product of x minus 1 times x squared minus 5x plus 6. So yes, so you see your f of x in some sense is divisible by this x minus 1. It's like saying 8 is divisible by 2, so then 8 is 2 times 4. All right? So now I want to solve, right? We want to solve. So this is the first step. Now I can do the second step, which is solving. Now I can solve my equation, right? So I want to solve. I want to solve f of x equal to 0, of course. So I want to solve. X minus 1 times. So we see why it's really important to have this factorization, because now if you want to solve your f of x equal to 0, because it's a product, because it's a product equal to 0, then you can say either the first factor is 0, so either the x minus. So if you had, let's say for some reason you had plus 2 here equal to 0, okay? And you want to solve the equation, then you cannot deduce anything, okay? You cannot deduce anything because of this plus 2, all right? So you need just a product. If you have a product equal to 0, then that's fine. You can solve your equation. But if you have like a multiplication and then addition equal to 0, then actually you cannot say anything, all right? So that's why it's really important that the remainder is 0. So because of my remainder is 0, so I don't have anything here. So I have just a multiplication, a product. So once you have just a product equal to 0, so then yes, you can solve your function equal to 0. So I was saying, so either x minus 1 is 0. So either this is 0 or this is 0. Okay, or oops.
Sorry, Professor. I
Yeah.
didn't get what you said. Like, you said
Yeah.
if the remainder wasn't 0, we wouldn't be able to solve it, or
Yes.
just
Yeah. If a remainder is not 0, let's say you have plus 2 here as a
yes,
remainder, right?
yes.
If I had plus 2 there, then I cannot say anything. I cannot say x minus 1 is 0 or whatever, right? So I cannot say anything here
Oh,
because of the plus. The idea of, the idea is when we have a product of two numbers equal to
yes.
0, then one of the numbers is 0, right? If you have 5 times 0, that would be 0, of course, because one of the numbers is 0. But if
Oh,
you have like two product of two numbers
yes.
plus another number equal to 0, all right? So you cannot say one of the numbers is 0, right? You cannot say my x minus 1 is 0 or this x minus 5x plus 6 is 0.
Oh,
Okay, because there is this problem. There's this, there's this plus 2,
yes.
and because of the plus 2, you cannot just say one of the numbers here is 0.
Oh, okay. Yeah, got it.
Yeah. That's actually the whole idea behind this factorization. So why do we factorize? Why do we bother to factorize? Because once you have when you factorize, it means you have a product. If you have just a product equal to 0, then yes, you can solve the equation equal to 0. But if you have like a product plus another number or minus another number equal to 0, then you cannot say anything. All right.
Oh, all right. Yeah.
So yeah, so now because the remainder is 0, so then either this x minus 1 is 0, so then your x is positive 1, or this x squared minus 5x plus 6 is 0. And now here, this is a quadratic equation, right? X squared is a quadratic equation, so I can use the quadratic formula, right? So it's just so then your x is either, so it's minus b, so it's minus -5 plus or minus square root of b squared. B squared, that would be -5 squared, that would be 25, minus 4 times a times c over 2a, so it's times over 2. So your x is positive 5 plus or minus. So 4 times 6 is it's 24. 25 minus 24, it's 1. Square root of 1, it's 1. So this is plus or minus 1 over 2. So the whole thing divided by 2, of course. So it's, so then x is 5 plus 1 over 2. That would be 6 over 2. So that would be 3. Or x is 5 minus 1 over 2. So that'll be 4 over 2, and that'll be 2. Okay, so we got 3 solutions. First, x equal to 1. That's from the x minus 1 equal to 0. And we knew we knew that the x equal to 1 is a solution, right? We knew that. Now, the new thing is that if x is 3, and I mean 3 and 2 are solutions, okay? So to answer, so now I can answer the question. So the solutions are x equal to 1, x equal to 2, and x equal to 3, right? And we should expect. Hi, Carolina. We are. Yeah, I'm not taking attendance actually today, so it's the last day of the classes, so we're gonna just take it easy today. Yeah, so the solutions, we have 3 solutions. That's because again, the idea, guys, is this is the degree of f of x. It's 3, right? It's x cubed. So when you have x cubed, the degree is 3, then you should expect 3 solutions, 3 different solutions, right? Of course, you expect 3 different solutions, but you could have less than 3 solutions, all right? Sometimes you can get only 1 solution, because when you use this quadratic formula, you can end up with something negative under the square root, and we are looking for, let's say, for real solutions. And of course, square root of negative number, it's not real. So it's not real number. It's going to be a complex number. So yeah, sometimes you can, of course, you can get less than 3 real solutions. But anyway, in general, you should expect having 3 different real solutions. All right, and that's our case here. Any other question, guys? All right, so yeah, as I said, you have to keep in mind, guys, so the final, it's not just about the second test, it's about the second test and the first test, right? So as I said to Kairali earlier, so you should expect, I guess, between, I would say, 8 problems. In this 8 problems, I don't know, let's say you're gonna have like 3-4 problems from the second test, and let's say 3 problems from the first test, and 1 problem from 1 problem about the trig, the trig. So I'm gonna do an example problem with the trig functions. But yes, so you should keep in mind, guys, that you're gonna have some problems from the first test, right? So for first test, I don't know if you have a copy of the first test, but I would say the main problems in the first test are about the domain of functions. Remember, domain of functions who are not allowed to divide by 0, not allowed to have negative numbers and the square root, etc. What else? We had also transformations. Remember, horizontal shift, vertical shift, etc. Also, the graphing parabolas, right? Khadija, you have a question. Let's see. How do you find domain f compose? Okay, yeah, that's actually a good question. Thank you. Probably, I think there is a 1 problem in the. So this is for the first test. So this is test number 1. So this is the test number 1, and the problem 2. Okay, so in the first, so you have your f of x, x plus 1, and g of x is square root of 4 minus x. So you have to find the domain of F, the domain of G, the domain of F over G, and then the domain of F composed with G. So for F composed with G, to answer Khadija 2 questions, so F composed with G, so there are 2 steps. I want to find a domain of F composed with G. Okay, so this is a composition, guys. This is not a product. It's not an multiplication. This is a composition. Okay. Yes, yes, Carolina. Yes, I'm recording the session. Yes, sure. So, sure, no problem. Yeah. So I was saying, how do we find the domain of F composed with G? So there are 2 steps. You don't have to. So okay. So you don't have to, find the domain of F. So first step is always. So step 1 is to find the domain of the second function. So my second function here is G. So I have to find domain of G. Find domain of the second function, which is G. Which is G in this case, right? That's my second function. Which is G in this case. All right, so in this case, my G of X, of course, is square root of 4 minus X. And we said, to find the domain of function, there are two things to check, right? There are two things to check. If you have a division, you have to make sure you have to solve the bottom equal to 0. So let me just remind you here. So just to remind you. So there are 2 things to check. So if you have a division, so you have to solve the bottom equal to 0, right? So if you have a square root, okay, you have to solve what's under the square root. Solve what's under the square root. Larger or equal to 0. Okay. So here in this function G, of course, I do have a square root. So I have to solve what's under the square root larger or equal to 0, right? So of course, if you have something else here outside the square root, like I don't know, plus 2x, where x squared, wherever, you don't really care about this. What's outside the square root? You only care about what's under the square root, right? So if you have something else outside the square root, you don't really care about it, okay? When you find the domain. So under the square root, I have this 4 minus x. So we need to solve 4 minus x larger or equal to 0. You can just do plus x, for example, both sides. So that's 4 less or equal to x. So x, your x is, we are saying here, x is less or equal to 4, right? X less or equal to 4. In other words, so here's my x is less or equal to 4. Okay. So then the domain of G, of course, you can use a number line, guys, if you have a trouble with the domain. I mean, if you want to visualize your domain. So here's the answer for the G. So domain of G, domain of the second function, domain of G is negative infinity, positive 4, and positive 4 is included because x can be equal to 4, all right? Now, so this is the first step. Find the domain of G. Now, the second step is to compute F composed with G. So step number 2. So you have to compute F composed with G, all right? And find the domain, compute and simplify. Sorry, here I should add simplify. Compute and simplify F composed with G. I mean, if it's possible. Sometimes, of course, it's not possible to simplify, but if it's possible to simplify F composed G, then simplify it. Okay, so so what's F composed with G in this case? Well, my f of x is this x plus 1, x minus 2. So f of g, f of composed with g. So that's by definition f of g of x. So what we do, guys, of course, is we substitute x by g of x. So my x in here, there's an x in the top, x in the bottom. So I have to substitute that x with the g of x. So it's going to be like g of x plus 1 over g of x minus 2. All right, so then, so my g of x, of course, is the square root of 4 minus x plus 1 over square root of 4 minus x minus 2. All right. Here, I mean, there's no real, I mean, we cannot really simplify here f of composed with g. So we're going to stop here. Now, the idea is to find the domain of this f composed with g. So what we do is, well, here we have a division, right? This is a division. We have a quotient. So we have to solve the bottom, right? We solve the bottom equal to 0. That's what we do when we have a division. Right, so we solve. We have to solve the bottom, so which is square root of 4 minus x minus 2 equal to 0. We're gonna add plus 2 both sides, so that's square root of 4 minus x equal to positive 2. You can get rid of the square root using the square both sides. So that's 4 minus x equals to 4. All right, so then you can subtract 4 both sides. So your minus x is 0. If minus x of 0 means, of course, x is 0. Okay, so in other words, I have to exclude x equal to 0 from my domain. Okay, so so we have to exclude x equal to 0 from the domain of G. Okay. So that's why in first step you find domain of G. Second step you try to compute and simplify this F composed with G. Try to find the domain, and then you have to exclude that from the domain of G. Okay, so domain of G was where is it? Domain of G. So domain of G, we said it's negative infinity, positive 4 included. Right. So negative. So domain is so G, domain of G is we said it's negative infinity, positive 4 included. So now to answer the question, so the domain of F composed with G, the domain of F composed with G is this negative infinity 0 excluded, right? Because we said we have to exclude the 0, right? X equals to 0 from the domain of G. So it's negative infinity 0 excluded, union 0 to positive 4. Positive 4 is included. Right. So that's the domain of F composed with G. So first step, domain of the second. First step is you have to find the domain of the second function, which is, let's say in this case, G. The second step would be to compute and simplify F composed with G and try to find its domain. And then you have to exclude that from the domain of G. All right. Any question, guys? All right, so what else? In the first test, so yeah, there is this domain, domain of f, domain of g, domain of f plus g, etc. You have also to check how we find like the domain and the range of graphs. Remember, for the domain we use vertical lines. For range we use horizontal lines. I think some of you had the trouble, like in the first test, the problem number 3, finding the domain and the range of f of x. Probably I can do that, and then I'm gonna do, of course, if there's also in the first test, there are some questions, some problems about the inverse function, right? So you need to know, guys, how to find the inverse of a function. Remember how I mean, you can check the recordings, of course, but uh, uh, you can check how we found how we find the inverse of a function, right? What else? There's also even odd and even and odd functions. Let's see. Yeah, and then determine of if g is the inverse of f. Anyway, so let me just remind you how to find the domain and the range of the graph of a function f. So let's say this is a problem, actually problem number 4 in the first test, right? This is problem test 1. Right, so okay, so we have this graph. Let's see, so here's my graph. Okay, it's not a good graph. This is not here. I'm gonna just all right, this is better. All right, so this is so my my f of x. So this is here's 1, 2, 1, 2. What else here? 3. This is 4. This is a -1, -2, and I'm gonna need probably a -3, and then I'm gonna need a -1. So the graph was so here -3, -1, and then here -2, -1, +1 here. All right, and then here we have a full dot, and then -1. Sorry, this is an open dot. This is an open dot. Here at +2, -1, we have an open dot, and then a full dot at 4, +1. All right, so here's, well, it looks like this is an open dot, of course. So this is my f of x. Anyway, so let's say you want to find the range, the domain and the range, guys. So I want to find first the domain. All right, this is x-axis, of course, y-axis, find the domain. So for the domain, guys, you have to use vertical lines. So whenever your vertical line intersects the graph, then that will be a point of the domain. Okay, so use vertical lines. And of course, in the domain, we care about x, right? We are interested in x, right? We care about x, the x-axis. Okay, so what I'm gonna do, I'm gonna take a vertical line. So for example, this vertical line here doesn't intersect the graph. So I don't have an, so it's not in the domain. Well, I'm gonna start having something in the domain at -3, right? Here at -3, right? I do have an intersection with the graph. So my domain is gonna start at -3, right? So here an answer, a -3. -3 is included because I have a full dot at -3. So I'm gonna include -3. Now, here, this line here, intersect. So I'm gonna have something in the domain. etc. But then I arrive at -1, and at -1, it's an open dot. And I remind you guys, open dot means that it's excluded from the graph. So I have to exclude -1 because it's an open dot, right? So from -3 to -1, excluded because it's open dot, union, of course. Next, just after -1, I'm gonna have something in the domain, right? We're gonna have an intersection. So just after -1, I'm gonna have something in the domain until you arrive at 0. All right, at 0 here, this is 0, of course. So at 0, that's a full dot, so it's included in the domain union. Then after 0, well, there's no intersection until you arrive at +2. Well, +2 is not included because it's an open dot. So here's my +2, not included because it's an open dot. And then gonna have intersection until we arrive at +4. So then +4, it's included because it's in a full dot, right? Make sense to you guys? Now, the range, we want to find the range, right? Now we want to find the range. So then find the range. So we're going to use horizontal lines. And of course, you start from the bottom. So we go from the bottom to the top. Okay, here for the vertical lines, you go from left to right. Right, from left to right. Anyway, so range, horizontal lines from the bottom. We start from the bottom, of course. Here, there's no intersection in the bottom. You arrive at -1. That's where we're gonna have something here. This is a full dot here, right? This is an open dot, but because we do have a full dot here, so the -1 must be included in the range. Okay, that's because we have a full dot in here, right? Even if we have a empty dot here, it doesn't matter because we have a full one here. Okay, so I'm gonna have -1 included, and then let's continue. We're gonna have intersections, still intersection until you arrive at the level, at the height of +1. A +1, this is an open dot. It doesn't matter because we do have a full dot here and a full dot here, right? So a +1 is gonna be included. So +1 is included. And of course, after +1, there is no more intersection. So I'm gonna stop here, and my range would be the -1, +1. All right. Okay, guys. I mean, 20. It's 23, so we have like around 20 minutes. So I'm gonna probably, if there's no more, no questions, specific questions about the first test or second test, I'm gonna do a problem about the trick. Okay, because it's gonna be in the final. It's in the homework 8 too, and it's gonna be in the final, right? So let's do a problem. So this is a problem about the trig. Okay, so it's in the final. Again, remind you guys what I said. The final is going to be a combination of the first test, the second test, and +1 problem about the trig, similar to the problem number 2 in the homework 8. Okay, so this is in the final. So trig. So for example, let's say you want to find the exact value of sine and cosine. So let's say you want to find sine of let's say 35 pi over let's say 35 pi over let's say 6. Okay, now so first So what you do, guys, there are two steps. So first step is to divide. So step one, so you have to find how many full rotations you have in this 35 pi over 6. So step one, find how many. So we have to divide 35 pi over 6 by 2 pi. 2 pi, that's a 360 degrees, and that's a full rotation, right? So by dividing by 2 pi, actually we're trying to find how many full rotations we have in this 35 pi over 6. So that's a full rotation, right? So I have 35 pi over 6 divided by 2 pi. Make a 2 pi as a fraction by dividing by 1. Division of two fractions, you flip the 1 in the bottom, so it's 35 pi over 6 times 1 over 2 pi. So then the pi in the top and the pi in the bottom cancel out. So it's actually 35 over 12. And when you divide 35 by 12, this is over 12. So when you divide 35 by 12, it's actually equal to 2. And then the remainder would be 11, right? So what does it mean when you divide 35 by 12 is equal to 2 and the remainder is 11? It means that you have two full rotations here in this angle. So there are two. So there are two full rotations. Okay, so what we do is we have to subtract two full rotations from my angle. Okay, so this is step number 2. Step number 2, we're gonna subtract two full rotations from my angle theta, from our angle. So our angle is the 35 pi over 6, right? And I'm gonna subtract two full rotations. So 2 times full rotation is 360. It's 2 pi, so 2 times 2 pi. So that's 35 pi over 6 minus 4 pi. Now, of course, this is subtraction of fractions, so we need a common denominator. So here, common denominator would be 6. I have to multiply by 6 the top and the bottom, right? So that's 35. So that's 35 pi over 6 minus 24 pi over 6. So that's 11 pi over 6. Okay. Now, so what I'm saying is that, so step 3, I'm gonna find now, I can find now the sine of my angle. So now I can answer the question. Okay. So what we are saying, guys, is that sine of this 30 pi 5 over 6, sine of this, my angle 35 pi over 6, is the same as the sine of what I got here. So I got 11 pi over 6, right? I subtracted two full rotations, so I got 11 pi over 6. So what I'm saying is sine of 35 pi over 6 is the same as sine of 11 pi over 6. Okay. Now, the question is, in which quadrant is 11 pi over 6? So what's 11 pi over 6? I mean, pi is 180 degrees, right? So pi is 180, right? So what I'm saying here is, so this is sine of what? So this is sine of 11 times 180 degrees over 6. Now, 11 times 180 over 6, so 180 over 6 is 30. 30 times 11, it's 330, right? So this is a sine of 330 degrees. So in which quadrant is 330 degrees? So this is 0, this is 90 degrees, this is 270, and this is this is 180. 180, and this is 270, right? So then, of course, and then when you do full rotation, that will be 360 here. So the 330, of course, would be in the here, somewhere here, 330 degrees. So that's in the fourth quadrant. So this is in the fourth quadrant. All right. So if it's in the fourth quadrant, well, we're going to use the reference angle, right? So then, so that will be equal to, so here, I'm going to use a reference angle in the fourth quadrant. And in a reference angle in the fourth quadrant is 2 pi minus our angle. Okay, so it's, or I mean, if you prefer, it's 360 minus our angle. That's the reference angle in the fourth quadrant. So it's 360 minus our angle is 330, right? So it's 360 minus 330. That's equal to 30 degrees. So what I'm saying here, guys, is that this is actually sine of 30 degrees. But now just be careful because we are in the fourth quadrant, then sine in the fourth quadrant, sine corresponds to the y coordinate, right? In the fourth quadrant, sine is negative. So I'm going to need minus here. This is a minus, right? Because we are in the fourth quadrant. So sine is negative in the fourth quadrant, right? So it's actually minus. Now, what's sine of 30? Sine of 30, you're going to use our table of special angles between 0 and 90. So sine of 30 degrees, it's actually half. So the answer here, it's negative half. Thank you, Carly. Yes, absolutely. So it's negative half. So you see, guys, you first you try to find how many full rotations you have in your angle. You subtract that number of full rotations, and then you're going to have an angle between 0 and 360. So you have to figure out in which quadrant is your angle, use your reference angle, and then you can get your answer. All right. Now, in the case we have, let's say, a negative angle. So this is there any question first, guys, about the 3 steps? So first step, let me just go over this problem again quickly. First step, we divide by the 2 pi. You see how many full rotations you have in this angle. You subtract that number of full rotations. So I got, when I divide my angle by 2 pi, I got 35/12. That's 2 and left with 11. So that's 2 full rotations. So I have to subtract 2 full rotations from my angle. That's 2 times 360 or 2 times 2 pi. I got this 11 pi over 6. Now this 11 pi over 6 turns out to be in the fourth quadrant, right? It's the 11 pi over 6. That's 330. That's in the fourth quadrant. Use reference angle, and then I get my angle, my sine. All right. Now, is there any question first, guys, about any of these steps? All right. So then, now in the negative case, I think probably the easiest way. I mean, there are different ways actually to answer all these questions, but now let's say in the negative case. So this is number 2, another problem. Problem number 2. So let's say you want to find cosine of negative, let's see, negative what? Let's see, negative, let's say negative 33 pi over 4. Okay. So I guess I think the easiest way would be to just to say the cosine is it's an even function. So let me just remind you that cosine of minus theta is equal to cosine of theta, right? Sine of minus theta is actually minus sine of theta. All right, so because again, cosine, we said that cosine is even function and sine is an odd function, right? Anyway, so the easiest, I think the easiest way here to say is we have this cosine of negative 33 pi over 4. So if you have a negative angle, and you want to find the cosine, probably the easiest way is to say, well, cosine of negative angle, because cosine is even, so that would be cosine of the positive, the same angle here. So it's so we can say that cosine of negative 33 pi over 4 is actually equal to cosine of positive 33 pi over 4. Right? Because cosine is even. And so now I got positive angle, right? So now I'm in the same situation as in the previous example, right? The previous example, I had to compute the sine of 35 pi over 6, but anyway, it's a positive angle. So when you have a negative angle, guys, my advice would be probably just to use the fact that cosine is even. And if you have sine, use the fact that sine is odd. So now I'm gonna just repeat the same steps, right? Because now all I have to do is to find the cosine of positive 33 pi over 4, because that's equal to the cosine of negative 33 pi over 4, right? So just repeat the same steps. Repeat the same steps as the previous example. Same steps as the previous example. Right. So first step would be to, just divide. Step 1. Just to divide this 33 pi over 4. Positive, right? Now I'm gonna work with positive. Okay, I can just forget about this minus, okay, because cosine is even, so it doesn't matter if it's minus 33 pi over 4 or plus 33 pi over 4, you're gonna have the same answer, right? So just divide this 33 pi over 4 by 2 pi as usual. So it's just 33 pi over 4 over 2 pi. So it's 33 pi over 4 times, flip the 2 pi, it's 2 pi over 1, so it's 1 over 2 pi. So cancel out the pi, it's 33 over 8. 33 over 8, it's 4, and 4 times 8, of course, that will be 32, and we are left with 1, right? So what we are saying is that there are four rotations. So I'm gonna subtract that from my angle. So that will be step number 2. So step number 2, subtract. So I have my angle, which is 33 pi over 4, and I'm gonna, as a first step, I said we have four rotations. I'm gonna subtract 4 times 2 pi. So that's 33 pi over 4 times minus 8 pi. Need the common denominator, times 4, top and the bottom. That's 33 pi over 4 minus 32 pi over 4. So that's equal to 33 minus 32, that's 1. So that's 1 times pi over 4. So that's just pi over 4. Okay. You see, now pi over 4. So now step number 3, I can answer the question. So step number 3. So this cosine of minus 33 pi over 4, we said it's just cosine is even, so it's just cosine of plus 33 pi over 4. And now I subtracted my four rotations, and I got this pi over 4. So that's cosine of pi over 4. Now, what's pi over 4? Pi is 180, right? So it's 180 over 4, 180 degrees, of course. That's cosine of 180 over 4, it's 45. So that's cosine of 45 degrees. Well, 45 degrees is just in the first quadrant. So we can just use the table, special angle between 0 and 90 degrees. So here I'm gonna just use the table because it's just in the first quadrant. So I don't need the reference angle, right? Because we are in the first quadrant. And cosine of 45, of course, is just positive square root of 2 over 2. Okay, so that would be the answer. So you see, so guys, in this negative case, all you have to do use the fact that cosine is even. And in the case of sine, so let's say if you had sine here instead of cosine, so then the only difference would be just so let's say here I had not cosine but sine. So if you had sine, let's say here you had sine, so here you're going to have minus sine. Okay, and then there's this, you have to keep this minus here, right? This is minus here, minus, and so the answer would be minus here. Okay, so that's the unique difference between cosine and sine. And the sine, it's odd, so sine of minus 33 pi over 4, that will be minus sine of plus 33 pi over 4. Okay, so then the only difference is that we're going to have this minus. You have to keep this minus all the time, right? So then the answer would be minus square root of 2/2. That's the only difference between the cosine and sine. All right. Anyway, so here, of course, the question is about cosine, not sine. So here is just cosine. This is cosine. This is cosine. This is cosine, cosine. All right. Any question, guys? All right, no questions. Good. All right. So how much time we're left? Like 9 minutes. What? Sorry. So probably I'm gonna, okay, thank you. So probably I'm gonna stop here, guys. I mean, I think I went over both tests, and well, of course, not all the, not everything, but I mean, I would say the main problems in the first and the second test, and also the problem about the trick. So probably I'm gonna stop here, guys. As I said, today I'm gonna just take it easy. So I won't go over time. But yeah, so I wish you good luck, guys, in the final. So the final again is the next Wednesday, from 9 a.m. to 11:50. I will post the final as usual on Blackboard. And again, keep in mind the final, it's not just about the second test. It's the second combination of the second test, the first test, and one problem, one trig problem. Okay. All right. Any question, guys? Nope. All right. So I'm gonna stop here, guys. Thank you, everyone. I wish you, of course, good luck in the test and then the semester. And I wish you happy holidays, of course. And I wish to see you next spring. Probably not the next spring, but probably next year in the campus, right? So take care, everyone, and good luck. Thank you.